Hi all. Let us start with the next video related to PCI course. In previous video, I started explaining on transaction layer. PCI protocol itself, we have a layer protocol. So in that, we have a three major layers. In that, I started first layer was transaction layer. In transaction layer, I already told you in previous video, we have a transaction layer itself. We need to generate the different types of TLPs, transaction layer packets. So we'll see once again a quick overview of our transaction layer. Then we'll move on to the different types of transaction layer packets. Just we'll see once again what is the overview of PCI layers. Uh, in this diagram, we'll see from the top left side we have a device A and in device B. Let us assume as a RC as a device A and EP as a device B. It's connected through link. So if from the device A, it's initiate the PCIe interface. So the device A initiated to let's do some operation to towards the device B side. So in what happened from the device A side, you will device core. It will start requested to PCIe interface. From the top level, you will get as a data like what type of request I have to send from the RC to EP. Let us assume here is a RC. Here will be the EP. You are connected through link. So from the device A from the top layers you will get as the information like what type of request I have to send from the RC to EP, what type of data I have to send, what whether it is memory or related or config, then what type of data I have to send, what type of tag I have to use, what type of request ID I have to use. So everything will get from the top layers. Once getting data from the top layers, transaction layer will do as a packets generation. So from the top layer you will get as a data. In transaction layer what happened, it will add as a headers and digest. Header means it's a header TLP. Header will append to the that data. As digest means it's kind of CRC calculation. ECRC we call as a ECRC, end-to-end CRC. So from the top layer you will get a data. From the transaction it will append to the header and digest based on requirement whether it's needed or not. It's up to we need to choose whether it is ECRC needed or not. Then after once the data is coming from the transaction layer to data link layer, it will add as a sequence number and LCRC. So let's take example as a I want to send 20 packets. Let us I will take as a 20 packets. So 20 packets means you will get as a one by one sequentially. So once reaching transaction layer to data linker, we need to add the sequence like what type of what is the sequence number of that TLP. So we will add as here is sequence number. That sequence number append to the left side and ECRC also append to the right side of that TLP in data link layer. Once data link layer is sent to file layer, it will add as a start and end field. These two fields will help you to it's kind of boundary conditions like what is the starting TLP. It will be the very clear to receiver when start bit is started. Next will be the I can able to see the sequence number. Next I can able to see the header type and data. So receiver it will very easily capture like what type of next field I am going to see. So we will add as a here is a boundaries of that TLP start and end fields. Once data is sending from your transmitter to receiver from RC to EP, in physical layer it will check what is the starting boundary ending boundary is whether it is correct. If it is correct, it will go to the data link layer. It will remove in physical layer EP side. It will where here left side we are appended. Here will be the removed from the TLPs. So once the start bit and end bit is removed, that remaining part will send to data link layer. Here we will check sequence number and LCRC. What happens sequence number, let us say you are sending data as a 20 packets, I already told. So let's say X sequence as a 1 2 3 4 sequentially, 1 2 3 4 5 6 like that. Whether it is able to see the sequence is proper or not, it will check here. Whether it is sequence is correct, it will send to that packet to transaction layer. In whether it is correct, if it's sequence number and LCRC is removed, remaining part will send to the transaction layer. In transaction layer, it will see the header, whether whatever data I am expecting, whether it is correct. Everything fields is everything correct. Whether it is ECRC is success, everything it's correct, then it will go the that data to other end of EP side. So in this way, in header it will mention everything, address everything. So based on that address, that data will store down to the device B. So in this way, the process will go on. So this is the overview of that transaction, all layers in PCIe. Now we'll see the transaction layer. How transaction layer generate different types of TLPs. So if you see here, uh, in transaction layer itself, we have a four types of TLPs. It's able to generate memory, IO, and configuration messages. In exactly transaction itself, we have only header and digest, I already told. So it will happen from the top level, you will get a data. Based on that data requirements, it will add to the headers and ECRC based on requirements. So in we'll see the first header part, then we'll see the payload, then we'll see the ECRC. So in transaction itself, in four types of TLPs, in four types of TLP, we need to see the header and the payload and digest. If you say as a membrane, for example, membrane means data is present, you are writing something data to that particular endpoint. So if you want to read membrane, you don't want to add any payload. So that is a very simple, you have a packet such a way that header, data, and ECRC. Header, data, and ECRC. If you are writing memory, if you want to read the data from your RC to EP, from EP to RC. RC will send the request. I want to read data so and so address. Let us take as a 0 to 15 address. I want to read the data. So EP will send that data. So what happened in that time? What happened? You have a only header. You don't want to add any CRC and data, because if you have a data, it's CRC calculation will be needed. Otherwise, it's no need. Just it will send as a header. Header it will mention everything like what type of data you want, how much data you want, what is the length you want, so which tag you are getting data. So everything it will mention in header type. So based on requirements, we'll see what type of TLPs it will generate in the transaction layer. So we'll go through one example for that, so you will understand very easily. So from the top layers, you will see the device ID, address, ID type, or requested ID, tag, packet length, how much length, what type of packet, data payload, traffic. This information, all information will coming from the device core A. So we'll see the packets format. So if you see in a packet format, this is a header type. Header. This called as a header of PCIe. This called as a header type of PCIe. So in that we have a different fields. Each field have its own significant format. What type of format? What type of which traffic class you are using, what is the attributes, what is the th means, what is meaning of td, what is meaning of ff. So everything, every field it's have a own significant based on requirements, which one we need to enable, which one need to be disabled, it's up to requirements. So we'll see the one example for that, so we'll understand very easily. So let's take, I want to take as a memread. So what type of format I want to send here is, if you see in a, this we call as a 32 bit. This is the 32 bits data. We'll see in a header type we have a mainly in a two types, whether it is three double word or four double word. This is the important point. Three double word or four double word. Three double word means it's up to two. We have a first two fields are almost similar. The third will be the 32 bit address or 64 bit address. two types of TLPs here is headers will be there, whether it is 32 bits addressing or 64-bit addressing you are doing. If you are using 32-bit address means what is the allocation of memory space. If you are using 64 addressing mapping, how much memory space you are using. It's up to requirement, based on requirement we have to follow up. So we'll see first field as a this first divide as a format type traffic class so and so. This field we'll see first. So let's I want to take as a membrane one example. I want to send a membrane packet from the RC to EP. RC to EP, I'm sending data. Membrane, I want to get the data. So membrane request, whether you are using three double word, you have to use a 000. Type will be the five zeros. So these values you should put in the header field. So here is the format is a 3 bits, types is a 5 bits. So overall 8 bits. This 8 bits will be filled with these values 000, 0000. If you are using four double words, means 64-bit addressing. If you are using 001, like that. If you are using memory lock request, it's lock request with a special feature from the transaction layer. So we'll see in a future slides how lock transactions is helpful. But for locking purpose, locking means it's kind of let's take one example here itself. You have a RC, you have a EP, you are sending data. You are whenever you are sending, you it should be locked that link. So what happen? It should not get any interrupt. Whenever you are sending lock transaction means it's kind of important. Important data you are sending to that link, so it's need to be complete first. So whenever a data is complete, then only it's going to be unlocked. So this is useful for the locking transactions. The one if you are using four double words, what is the value? Membrane, what is the value? IO request, IO write, configuration, read and writes, what is the value? So everything it will be the very clear. 8 bits data, which data we are going to give based on request from the device A. So based on request A, we have to provide appropriate data. If you see any message TLPs, message TLPs we'll discuss in the further slides. Yeah, as of now, just assume as a message TLPs as of present. These TLPs, if we it will be the fix four double word. There is no three double word. It will be the fix for four double words. This RRR indicate I will explain with examples. Just as of now, RRR means it's kind of redundant. Whether it is zero is present, whether it is one is present, we cannot tell. Based on requirements, we need to put that values zero and one. Here is a completions means it's kind of the data. It response, it's not data, it's response. Let us take one example. You have a RC, you have a UP, you are requesting membrane. So whenever you are reading data, you should get the data from the EP to RC. So RC is sending request to getting data. So EP will get data from the with completion. Completion means it's kind of response. Means response, whether you are getting completions with the data. Here you will get as a completions. Your completion with the data. You are reading data, right? So you are getting with completions with the data. So it's kind of completions. What type of completion you are getting? Here if you see three double words, what is the values we are putting here from the EP side to RC. One more is the fetch and the these are the atomic operations actually. Atomic operation I will explain with a suitable example. As of now, understand why it's needed atomic operation means it's kind of let us take one example. You have a RC, you have a EP, you are say let's do membrane. One example is a membrane. You are writing data with let us assume 1010 data. You are writing one address of EP side. So you will write the data from the RC will send the membrane request. So this data will be write into the EP. If you are reading data means another if you are if you want to read the same data means you will send again request from the RC. You will get the data from the EP to RC. So in that time what happen? Membrane and membrane you are sending two different requests. But instead of doing two requests, we have to improve the performance point of view. We are introducing atomic operations. So introducing atomic operation, what happen? Membrane and membrane both can also we can do at a time, same time. So because of this is a future for improving the performance point of view. In a transaction layer, we are generating these packets. One more is the unconditional swap. This I will explain. Swap and compare everything I will explain. So these are the fields we have to give the values based on requirements from the top layers. We have to give the values accordingly. So this is the first be format and type. We'll see the remaining values like in the next video. We'll see what is the TC values, what are the attributes, what is the ordering, what is the EP value, what is TD, so we will see the with suitable examples. We'll see that those bits. If you have any question, please let me know. Thank you.